Okay, so we're going to go through cardio. Cardio is charge, atom, resonance, dipole slash induction, and orbital. So what we're going to do is go through each one and do examples. So charge, for a charge, if you have an acid is more positive, a base is more negative. This is also order of importance from greatest to least. So let's get some examples. So for acids, we're just looking for the one that has a positive charge or is more positive. This H2O example, H3O plus is more positive. NH3 example, NH4 plus is more positive. That's how simple it is for at least these small ones. This example, the NH3 will be the acid because comparatively speaking, it is more positive than this negative NH2. Moving on to atom. Atom, the more electronegative or the bigger, the more electronegative and bigger atom, the more acidic. The less electronegative and smaller atom, the more basic. So, I'm not going to do all of these because some of them I think it would be nice for you guys to do on your own if you don't have these on the SI sheet already. But here, let's just do this one. This is a simple one. HF versus HI. When we reference the periodic table, what we find is, if we go down here, there's trends, right? Periodic table is very important for trends. From the bromine to fluorine, left to right, you're getting smaller. From fluorine to iodine, top to bottom, you're getting bigger. So keep note of these things when you're comparing elements. Okay, so let's compare HF. We're really comparing F to I, comparing size. Fluorine is in fact like the smallest element because it's the most electronegative. So off rip, you ain't finna find something that this is going to be the more acidic one because it's just bigger. Fluorine is always kind of going to lose out when it comes to size because it's just small. It's very, very small. SHOH, if you look at the sulfur is bigger than oxygen, therefore it's the most acidic. And vice versa for basic, right? OH is going to be the most basic because it's a smaller atom. Resonance is very important because it tells us a lot about acidity and basicity. So let's look at these. Okay, so we got to figure out, my question for this one is what's the most basic? Okay, so now we've learned about charge, atom, now we're on resonance. So what's interesting about resonance is that if you withdraw electrons, you're more acidic. If you donate electrons, you're more basic. Okay? And that's another way to describe it. But in reality, what you're trying to figure out is which one of these is just gonna be better at pulling off some stuff, right? Off rip, I will tell you that this is gonna be the most basic. A couple of reasons why. We're looking at resonance. This one has resonance. The most resonance, the most acidic. And then vice versa. Less resonance, less acidic, aka more basic. That's how I like to think about it. I don't really think about the withdraw and donate, but if it has more resonance and you're comparing the two, that's going to be the most acidic one. So it's going to be the least basic one. And it's vice versa for resonance. So again, like the more resonance, the more acidic. The least resonance, the more basic. Dipole and induction. Dipole and induction is literally how much these elements pull on each other, or pull on the molecule, right? Fluorine is very electronegative, so it's going to pull way more than bromine. This is going to be the stronger acid. So more electronegative atom, acidic. The least electronegative atom, basic. But let's look at this one. This one's interesting. Both of these fluorine, the fluorine is here, but it's one's closer than the other. Another rule of thumb is that if they're two of the same, the one that's closer, or in general, it doesn't have to be the same, the element that is closer to one of the main like group and more electronegative, that is the more acidic one. So this one will be most acidic simply because fluorine is electronegative, and even though they're the same, fluorine's a lot closer. It's here instead of here. So, oh, and then we have orbital. An easy thing for orbital, the shorter the orbital, the more acidic it is. So sp, sp2, sp3, those triple bonds are more acidic than double bonds, right? Double bonds more acidic than single bonds. So it's pretty straightforward. So that's kind of cardio. Go back through it, and hopefully this helps you.